Hello everyone. So my next PowerPoint, my next lessons for today. Would now be properties of rational roots or rational exponents as well as radicals. Okay. So this is the continuation. Okay. Now last time you already know the properties of exponents. That is, if it's the same base, you add exponents. Okay. Or when you divide, you just subtract exponents. Okay. So that's also true when you're dealing with exponents that are fractions. Okay. So again, when you have that, when you have product of powers, okay, so it's going to be, you add them. When it's a power to a power, you multiply them, and then you can distribute the power, okay. Then when the exponent is negative, you can put it down to make it positive, okay. And then quotient, you just simply subtract, okay. And then power of a quotient, you just simply distribute the m, okay. So basically, you'd learn this in Algebra 1, but this also applies to exponents that are fractions, just like this one. So 5 to the 1 half is 5 3/2, just simply add. Then this one you have to multiply, okay? Then you multiply the 1/2 to each, get the square root or get the simplifications, and then you multiply, okay? So we're going to use these properties in simplifying rational exponents, okay? So let's have an example, okay? So first example, just like this one, 7 to the 1/4 times 7 to the 1/2. So it's the same base. All you got to do is add exponents. So that's going to be 1/4 plus 1/2, and that's going to be 7 raised to the 3/4. So the next one, you can distribute. So 6 to the 1/2 times 4 raised to the 1/3. So I can distribute the 2 to each. So distribute the 2 here to 6 to the 1/2. That's 6 1/2 squared, and then 4 and raised to the 1/3 raised to the second. And then all I got to do is just simply multiply. So 1/2 times 2. So the 2 and 2 cancels out. So 6 to the 1, that gives you 6. And then 1/3 times 2, that gives you 2/3. So this whole thing is the final answer. 6 times 4 raised to the 2/3. Okay. Here, you have 4 to the 5th times 3 to the 5th raised to the negative 1 over 5. Okay. Notice since they have the same exponents, 5th, so I can take them out. So I have 4 times 3 raised to the 5th. Then raised to the negative 1 over 5. But 4 times 3, that gives me 12, right? So it's 12 to the 5th raised to the 1/5. So multiply 5 times negative 1 over 5. So the 5 cancels out, leaving you with 12 to the negative 1. Making the exponent positive, just simply bring it down. So it's going to be 1 over 12. And then the next example. So it's 5 over 5 raised to the 1/3. So remember, the exponent of 5 is just 1. So it's just simply 1 minus 1/3. That gives you 5 raised to the 2/3. And then the last one, again, that's going to be 42 raised to the 1/3 divided by 6 raised to the 1/3 squared. Now they have the same 1/3, so I can take that out, okay? And then I simplify what is 42 divided by 6. That gives me 7 right there. So it's 7 to the 1/3 raised to the second power. Just multiply 1/3 times 2. That gives me 7 to the 2/3. So this is just illustrations, okay? You have a lot of examples also in the textbook you can refer to, okay? So we're going to use this when simplifying radical expressions. So this actually properties came out from the properties of exponents. Remember, if you have something in the product of a root, nth root, you can just simply separate them. So like say if you have the same index, cube root of 4 times the cube root of 2, you can put that on the same index and then just simply multiply 4 times 2. 4 times 2 is 8, which means cube root of 8 is 2. Okay? Also, if it's one fraction inside the square or the radical sign, so the same index, you can separate the index if you want, making sure that b is not equal to 0, just like this one. Okay? Let's have an example. Okay? So here, cube root of 12 times cube root of 18. Okay? So you can put them into one single cube root. So it's 12 times 18, and 12 times 18 is 216, and then when you simplify this, cube root of 216, you're going to use your calculator here. That gives you 6. Okay? Like this one. Fourth root of 80 divided by fourth root of 5. You can put them into one single fourth root. Simply 80 divided by 5, which is actually 6. And the fourth root of 16, that gives me 2. Okay? Now, another way to say when a radical is in its simplest form, if these conditions are met. Okay? No radicands have perfect n powers as factors other than 1. No radicands contain fractions. Okay, so which means no radicals has no fractions. Okay, there's no radicals that appear in the denominator of a fraction. We're going to discuss all of these three. Okay, so when you say no radicals have perfect n powers as factors other than 1, which means there's no other power other than 1 that radicand that radicand has. Okay, what do I mean by that? Okay, like this one. Okay, so say if we want to simplify cube root of 135. Now you have to break up 135 in such a way that 1 has an exact cube root. So this one you have to use your calculator, trial and error, finding a factor. Okay? So eventually when you try to factor 135, you get 27 times 5. Notice that 27 is an exact cube root. Now, since this is a product, I can separate them like that. Cube root of 27 is 3 right there, and then simply copy cube root of 5 because this cannot be simplified anymore. That's the simplified version. So which means this 2 together is the correct answer, which is 3 times 3, the cube root 3 times the cube root of 5. Okay, second example. Okay, so cube root of 5, fifth root of 3 divided by fifth root of 2. Okay, you can put that in this case. Okay, now here you're simplifying the denominator, kind of like rationalizing because you don't want any denominator in there. Okay, now this is 2 to the fifth, fifth root of 2. Now, what expression would you multiply this denominator here in such a way that it will simply become what? 2. Now, since the index is 5 and this is 2 and the power of 2 is 1, what number do you need to add to 1 to come up to 5? That is 4. Okay? So the expression should be the fifth root of 2 to the fourth, because 2 to the fourth and 2, that gives you 2 to the fifth, cancel with the 5 gives you 2. And then since these two are the same 5, you can just simply multiply the insides together. 2 to the fourth is 16, and then that multiplies to the 3 right there, and that gives you 48. So your final answer is the fifth root of 48 divided by 2. Okay? Now another one is simplifying using the conjugate. Okay, when you say conjugate, it's the same term but with opposite signs. So if this is the conjugate of a squared of b plus c squared of d, would be just the same thing. The only thing is that it's minus. Or if you have the minus, the opposite is a what? Plus. Okay, example. Write 1 over 5 plus square root of 3 in simplest form using rationalization. Okay, so I'm going to copy that. I'm going to explain this. So I copied this down here. Okay, so what I'm going to do is to multiply this expression by the opposite or the conjugate of 5 plus square root of 3, which is the opposite of plus, which is what? Minus. So what I'm going to do is just simply multiply top to top, bottom to bottom. So 1 times 5 minus square root of 3, which is actually the ones in here. Okay, and that end up to be the same thing because it's times 1. And then remember, this is opposites, difference of 2 squares. So it's going to be 5 times 5. That gives 5 squared. And square root of 3 and square root of 3, that's going to square root of 3 squared. Now, square root of 3 squared is just simply 3. 25 minus 3, that gives me 22. So this is my final answer. Okay, let's have another one. Okay, simplify x over square root of x plus square root of y. So what I'm going to do is multiply this expression by the opposite. So if this is plus, multiply by the minus. Multiply the ones on top as is, so that's going to be it, right? And then square root of x times square root of x is just simply x. Square root of y minus square root of y would be equal to negative 1. So that's going to be the final answer, okay? Now, we're going to simplify radicals generally, okay? Using also factors. I'm going to teach you a simpler technique, and this technique is applicable to most simplifications, okay? You just have to listen carefully, okay? Example, write each expression in its simplest form, okay? This one. So cube root of 64y to the 6, okay? Now I have to express 64 as a power that has an exponent of 3, okay? So I can express 64 as 4 to the third and y to the 6. Okay, how did I end up getting 4y squared? Okay, so this is what you do. Look at the index and look at the power. So here, the base is 4. So for the base is 4, 3 divided by 3, that gives you what? 1. That's why it's 4 to the 1, or simply 4. Now let's go to y. Y exponent is 6. What is 6 divided by 3? That's 2. So the answer is y squared. Okay, kind of like easy, right? Let's have another one. Okay, the fifth root of, okay, the square root of 4, a to the 8, b to the 14th, c to the 5th. Okay, this one you listen carefully, okay? Because you already see the answer, okay? But how come the answer is like this? Okay, because I went straight from here going to the answer, okay? So, to do this, okay, let's start first with the number. Okay, 4 cannot be put out because there's no fifth root of 4. So the 4 still is inside. Okay? Now let's go to the first letter, A. The highest power in 8 that's exactly divisible by 5 is what? 5, right? Because 5 divided by 5 is 1, right? So 5 divided by 5 is 1, which means I have my A here. That's A1. Do you guys follow? Now, I took 5 from 8. How much am I left with? 3. That's the ones left inside. Do you guys get me? Okay, let's go to B. What's the highest power in 14? That's exactly divisible by 5. That's going to be what? That's going to be 10, right? Because 10 divided by 5 gives me what? 2. That's why you have now what? B squared. Do you guys get me? So which means I took 10 from 14. How much am I left with? That gives me what? 4 right there. Okay? Then the last one, let's go to C. Highest number in C, which is 5. Exactly divisible by 5 is 5, the whole thing. So 5 divided by 5, that gives you 1. That's why it's 1C. So you took all of this, so there's nothing left inside. That's why whatever's left inside is the final answer. So you took out A, B squared C times the fifth root of the square root of fifth root of 4, A to the cube, B to the 4. Okay? So our online classwork will now be on Delta Math. Okay? You're going to look under the topic properties of radicals, and the deadline for that is May 1st, Friday. Okay? Thank you, guys.